Hello viewers, welcome to Project Labs. In today's edition, we are going to discuss AC circuits. And in AC circuits, we'll talk about the AC waveform. The topics we are going to discuss will be based on these objectives. By the end of the lesson, we will be able to measure peak-to-peak voltage. We will be able to measure the RMS voltage, find period, and also calculate for frequency of waveform. This will all be done practically. The equipment you are going to use for this exercise are the dual trace oscilloscope, signal generator, and a frequency counter. We are also going to use a breadboard, of course, with some solid state components. The oscilloscope can be used to measure can be used to take a lot of measurements. These include the peak-to-peak voltage of a waveform. We also can find the period which will end up determining the frequency of a signal. So without wasting much time, we'll begin our practical. So the first thing we are going to do is to draw the AC waveform itself and how we can analyze it. So let's draw the AC waveform. Which is VT. Okay, so this is the AC waveform. Now, this is the peak voltage, the highest peak, the highest point, and then this is the lowest voltage. This is the lowest voltage, which is we refer to as peak to peak voltage. Then we have the RMS, which is the root mean square voltage. We'll be talking about all this. Now, if we say instantaneous voltage, by saying instantaneous voltage, we mean that voltage voltage which is instantaneous is equal to the peak voltage times sine of 2 pi ft, sine 2 pi ft, okay, which is the period. So we have the peak voltage, we measure the peak voltage, then we find sine of pi, which is a constant. The pi is a constant, which is approximately 3.142. The frequency is measured in S, and then the time is a period. The period within one wave cycle is one full wave cycle. The period within. Then we'll find the instantaneous voltage. We'll find the instantaneous voltage. We can convert this also. We have VRMS, which is root mean squared value, will be the instantaneous voltage with the peak voltage. The root mean squared voltage will be peak voltage times 0.707. Yes, this constant. So we will have to prove all this by generating a signal using the signal generator. Then we'll monitor it with the oscilloscope and also measure the frequency using the frequency counter. So we set the equipment for the experiment.